Alright, this is a video for problem number 47 on problem set 2 for week 2. So, number 47 of problem set week 2. And the question says, the uniformly charged straight wire in figure 2128 has the length L, where point 0 is at the midpoint. Show that the field at point P, a perpendicular distance x from 0, is given by the equation they have written here. E equals lambda over 2 pi epsilon naught times L, the length, over x times L squared plus 4x squared quantity square root. And I'll write that out just so we can see what that looks like. Okay, and that's the answer they said for the electric field of a figure that I'll draw right here. We have a charged wire and its perpendicular bisector that we're calling the origin has the length L. We have our point P that is some distance x from the perpendicular bisector. We derived earlier in our lecture and in one of the problems, I believe, the electric field equation for a point perpendicular to the charged wire. If not, you can go check back on your list. And we said that was equal to electric field of a finite line, K lambda L, over the height, h, the square root of h squared plus length divided by 2 squared. And that was the electric field of our finite lines. So with the information they give us for this problem, we are attempting to prove that this equation is indeed equal to the equation given to it for a finite line. So these two equations should should be equivalent for the figure that we've drawn here. So if we plug in the values we already have L as length, so that's fine. We have our height x, so we can say E for the finite line is K lambda L over x square root of x squared plus L over 2 squared. Okay, so we've substituted one of our values for the value in our figure. One piece you'll notice here is this lambda over 2 pi epsilon naught. K, our constant, is equivalent to 1 over 4 pi epsilon naught. And lambda will just fall over where the 1 is. So if we substitute that into our field equation for a point above the perpendicular bisector, we get lambda over 4 pi epsilon naught times L over x square root of x squared, plus we can simplify the denominator inside the square root and call it x squared over 4. And so we've found most of one part of our new equation and most of one part of our second equation, or the two parts of our overall equation that we're solving. So you'll notice here we have a 2, we have a 4, here we have no denominator under the length and 4 times x squared. So we're going to use algebra to figure this one out. We know if we multiply the top and bottom, if we multiply a fraction, we have to multiply the top and bottom by the same number. If you'll notice, L squared here is multiplied by 1 plus x, which is multiplied by 4. So here, there's no denominator on L. So what we can do is we can multiply a 4 into the square root. To multiply a 4 into the square root, you have to multiply the overall fraction by 2. and then the 2, when it falls into the square root, will become a 4. So then we get E is equal to lambda over 4 pi epsilon naught 2L over x square root over, let's just write 2x for now, 2x squared plus L squared over 4. By having this 2 here, the 2 is equivalent to the square root of 4, and when you multiply square roots, if I take square root of 4 times square root of x, we can write it as one piece and call that square root of 4x. So we can do the same with the 2 here, so we can just write that into the square root. So here you see, by multiplying the 2, or square root of 4, into this square root on the denominator, we got our 4x squared from the equation that we're solving, and we got our L squared too, and this half power is equivalent to the square root under here. So we figured most of this out, and if you'll notice we have a 2 in our numerator, we're multiplying these together, so 2 in our numerator, 4 in our denominator, so the 2 will cancel and reduce the 4 to a 2. So we've proven that the equation for the electric field of a point above the perpendicular bisector of a finite line, our E equals k lambda L over h square root of h squared plus L over 2 squared, is in fact equivalent to the equation derived by the question of lambda over 2 pi epsilon naught times L over x times L squared plus 4x squared to the half power. And we can rewrite that here. So we'll get 2 pi epsilon naught L over x square root of 4x squared plus L2. Check.